Hello, my wonderful computer science students. Welcome to another lesson in Unit 1, Using Objects and Methods. This is going to be Lesson 6 for us, which is all about creating and calling objects methods. So in Lesson 5, we learned about what an object creating class is and how we create objects. And now we're going to focus specifically on the methods involved in object creation. So we're going to talk about the different types of methods, both void and non-void, methods with parameters, without parameters, methods with return statements, without return statements, all of that fun stuff, right? And then overloaded methods as well. And we're going to be going through plenty of examples throughout all of this. And then we're going to finish the lesson talking about documentation with comments. Okay, so it's kind of a beefy lesson, but I'm excited to have you guys along with me for this. Okay, so we briefly talked about methods in the last lesson. We said with our objects, methods work as behaviors. So any behaviors we want our objects to have are created using these methods. And methods are blocks of code designed to perform specific tasks. Now, in the examples today, we're going to keep it very simple, like 1, maybe 2 lines of code in each of these methods, just so we can start getting the idea of what methods are and how we might use them. Now, to first introduce methods, we have to talk about the method header, because the method header is going to define our method and really tells us everything we need to know about the method itself. Okay, so here's a method header, and a method header is always going to start with a modifier. Now, a private modifier means that the method can only be used inside the class, versus a public modifier, the method can be used inside or outside the class. Now, in our AP CSA course, most of our methods are going to be public. There's very few times where we would need to have a private method, but if it does come up, a private method can only be used within the class that it is defined. So we always start off with a modifier. The next thing we have is our return type. So you can see highlighted there, I have the word void. It's a return type. Void specifically does not return a value. Void methods are used to perform actions. Usually we print something off, maybe to the console, or we update some of our instance variables, some of the data with some value. They don't actually return anything. Non-void methods actually return a value, and inside of the method, they'll have a return statement somewhere. And then whatever they return, that is the type, like if they return an int, that's the type that has to go in this green box here. So if they return an int, instead of the word void, I have to have int. Okay, or any whatever data I'm working with there, right? Non-void methods are used to get information in some way, or maybe to calculate a result. Okay, so we'll see some examples of that. Next is the method name, and that's going to come right before those parentheses there. Now, the method name identifies, of course, the method you'll be using, so it can have any name. It's like a variable. You can name it anything. By convention, these usually start with a lowercase letter, although they don't have to. Kind of like how our classes always start with an uppercase, but they don't technically have to start with an uppercase. So all methods will start with a lowercase, and they usually are descriptive of what the method does. Okay. And then lastly, in the parentheses there, we have parameters. And we first introduced parameters in the last lesson when we talked about our parameter constructor. And parameters can also happen in our methods, and they work in much the same way. Parameters represent values that are passed into a method so that you can use those values to perform whatever the method's task is. They act as placeholders for the data that you pass it. So you're going to pass the method data, and then the method's going to do something with that data. Okay. Parameters let methods work with different values each time they are called. So they allow for that flexibility in a program. If you don't have any parameters, then those parentheses are empty, but you do have to have those parentheses there. So in this case, in this example, public void speak, there's no parameter. So this is a no parameter method. Okay. And parameter methods will identify the data type followed by the identifier for the value you pass it, just like parameter constructors. Okay. So to talk about these methods, we're going to introduce some methods in context of our dog class. So I want you to look there and remind yourself of our dogs. Okay. Public class dogs, we talked about instance variables. We have the 3 instance variables at the top there, our default constructor, and then our parameter constructor. So all of that is laid out already. We made this in our last lesson. Now we're going to add on some methods. The first type of methods, we're going to add 2 methods that are void methods in dogs. And these we've actually brought up before. The first one is going to be speak. Okay, so you see there, that is a void method called speak. Okay, so you see the term void, and that's because if you look inside that block, what it's going to do is print to the console, woof, 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 woof. Okay, that is what the dog object is going to do when you call on speak. Okay, so it doesn't return anything, it just prints to the console. Here's another type of void method, public void have birthday. Okay, so in this one, you can see, again, the void and the method signature, both of these have no parameters. When you call on have birthday, what's going to happen? This time I'm actually using our data, okay, the data age. So whatever age is for your dog object, in this method, when it's called, it's going to increase age by 1. Right? When you have a birthday, your age increases by 1, and it's going to be the same thing for our dog. So these are going to be 2 methods I'm going to add to our dog class. Both of them are void, and both of them have no parameters. Now let's talk about non-void methods. So non-void methods are going to return a value of some kind. So here's our first example, public string say name. Okay. So again, see the string, instead of the word void, I have the word string, and that's because my method is going to return a string. There's still no parameters in this method, but inside of this block, of this method block, I have the keyword return. So this is a keyword that needs to be used in non-void methods. And what am I going to return? I'm going to return a string. Okay. This string, it says my name is in the quotation marks, and then I'm going to concatenate it with name. Now, what did name represent? Name was an instance variable that represented the name of the dog. So depending on what the dog's name is, you are going to return that dog's data. Okay. So it's going to be pushed together with my name is, and then that dog's information. Here's another example, public int people years. So again, this is a non-void method. This one returns a integer. Okay? And what does it return? Again, you see the keyword. We use the same keyword every time, age times 7. So this takes the age of your dog, whatever dog you are currently using, and multiplies it by 7 and returns that value. Okay. Now, very important that with this return statement, it does not update age's value. Okay. You can only do that with an assignment. You have to have your equal sign or a compound operator using the equal sign. Here it just says take age times 7 and return that value. You're not actually updating age at all. You are just using it in an expression. Okay. So those are 2 non-void methods in dogs. Now let's talk about parameters. We're going to first go through 2 void methods with parameters in dog. So we're going to add both of these. Here's our first example. Public void change it. Change name, not change it. Change name. And then in parentheses, we have string new name. So what happens here? Well, again, notice how it's void, public void change name, and how it has a parameter now, new name. So this parameter, it's a string. So you start with the data type, and then new name is going to be the identifier for it. That means when I call on this method and I say, hey, change name, that means I'm going to pass it some data. I'm going to put some data in there, and then that data is going to go under the new name. Okay. And then that new name, whatever that new name is, it's going to get stored in name. Okay. I'm using the assignment operator. So name is actually going to get changed to whatever new name is. Okay. So we're using a parameter to, in this situation, update some of our instance variables. Okay. And remember, we can change instance variables as long, because they're private, we can change them as long as it takes place in our dog class. And this is going to be added to our dog class. So I'm able to change my data there. Another void method is public void change goodness. Okay, so here again, I'm changing the goodness. I'm going to pass it a Boolean value. Whatever I pass it, the data is going to be called is good. And then it's going to be used as a placeholder to eventually go inside and change that instance variable good dog for whatever dog I'm calling on. Okay, so both of these are void methods with parameters. A lot of methods. The last type of method, non-void method with parameters, because there's four different categories here. So this is the last category. Non-void method, meaning that we are going to return a value and we're going to have parameters in here. So here is maybe our first one. Okay, public string get description string separator. Okay, so notice it's non-void because I am returning a string. It says public string, so I'm going to return a string value. And then in parentheses, I have string separator. So again, that means when I call on this method, I'm going to pass it some data that's going to be stand for the separator. Okay, so that separator is going to be a placeholder for this right here. So whatever data I pass it, that data is going to get put right here. I have a return statement. And what am I going to return? I'm going to return all of this. Okay, what is all of this? All of this is name concatenated with, because name is a string, concatenated with the string separator, concatenated with this string, concatenated with the age. Okay, so this is going to return all of this sort of pushed together, all of this data pushed together. Name and age. Remember, those are both instance variables of the dog. So I'm going to have specific data pushed in there from my dog object. Separator is going to get pushed into there as a parameter. And then this string is just always going to be there. Okay, that's just age. It's in quotation marks. That's always going to be there. Okay, here's our last example of a non-void method with parameters. So int is going to be my return value, and inside parentheses, I'm going to put int other dog. Okay. Now these data types, they don't have to match. It's just kind of a coincidence they both match here in this example, I'm now realizing, but they don't have to match. Okay. You can return an int and pass a string. Don't have to match in any way. And you can have more parameters. You don't have to have a single parameter, but I'm trying to keep it, as easy as I can right now since we're just learning about it. So I'm passing it in int other dog age, and whatever integer I pass it, it's going to be used in this expression. This expression is going to return age minus other dog. So whatever age of my dog is minus the other dog. Okay, and it's going to return that value as an integer. And remember, it just returns that value. It does not actually update age at all. Okay, the return statements just return an expression. Okay, it evaluates it and returns that value. Okay, just like this is an expression here, it's going to put that expression together and just return that expression to whatever method called it. It's not actually going to change anything about the data. Okay, all right. Let's put that all together. Okay, I just made 8 new methods, which is crazy. I made 8 new methods. So let's talk about how we call them. Okay, so all the 8 methods we just went over, they are now all part of our dog class. So all of them were in our dog class because they all worked with our dog data. So now when we create dog objects, we can call on those methods using the reference we create for the dog object. Remember, the reference is this little container that's labeled with our reference, and it's this little container that is actually going to point to where our dog's data actually is. The container doesn't hold the data. The container points to where that data is. Okay, so that reference, we go to that reference and it says, okay, we're going to use this reference. We're going to use it with that data over there, and it points it to it. Okay, so remember, these are our 3 instance variables for dogs. So I put this up here as a reminder. And then here's going to be our driver class with our main method. So I'm going to use my 3 dogs that I created from my last class. I'm going to call them dog 1, dog 2, and dog 3. Okay. Dog 1 is going to be constructed with our parameter constructor. The name is Mila, the age is 9, good dog is true. Okay. So this is what I mean. Dog 1 is the reference variable. Okay. And it's the container that holds the address for where the data is located. The container doesn't have the data. The container says where that data is located. So dog 1 says, okay, this is the data for this dog object. Dog 2 says, okay, here's the data for this dog object. And then dog 3, here's the data, again, for this dog object. So we have 3 dogs. So all of this we covered in last lesson. Now, what are we going to do with these 3 dogs? Now we're going to use the methods. And we're going to call in the methods, and we're going to do stuff with this data. Okay, it's exciting. Let's do stuff. Okay. So we have these 3 dogs. There's a lot going on the screen right now. So let me explain how this is going to work. Here are the 3 dogs we just created. So these dogs have already been created with code and are currently present in our memory. Okay. Over here in this box, I have all of the 8 methods we just created together. Okay. I have the 2 void no parameters. I have the 2 with return values, no parameters. I have the 2 void with parameters. And then I have the 2 with return types and parameters. I gotta keep that straight because we made a lot. We made a lot, but we're going to put it all together now. It's going to be beautiful. We have our methods that we created. Again, these are in our dog class. And then we have these dogs that we created over in our other class. Okay. So we're going to go through different code segments and figure out what it does. Our first example here is dog1.speak. Okay. So this is an example of calling an object's methods or an instance method. Okay. So dog1.speak. So that dot, that's our dot notation. That's what we actually use to call a method. In front of the dot, we put our reference, okay? Our reference variable. That is referencing what object we are working with. So dog1, that means we're working with this girl right here. Okay. This beautiful brownie here. Okay. We are working with her. So dog1, we are working with that object. Now, what are we going to do with that object? We're going to call on speak. So we're going to, since dog1 is a dog, this says we go over to the dog class and we're going to look for the speak method. Okay. Where is the speak method? Here she is right here. Okay. And what's going to happen? Okay. Dog1, I'll get rid of that text here. Dog1, we're going to go to speak and we're going to print woof woof. It's going to get displayed to the screen. Okay. Woof woof gets displayed. Beautiful. That's it. That's the line. That's what it does. Okay. Let's go through some other types of code. Here's dog2.haveBirthday. Okay, what's going to happen with dog2 have birthday? Well, dog2 is our reference and have birthday is our method. So we're going to go dog class, look for have birthday. Java finds have birthday. And what's going to happen? Age plus plus. Now remember, this is a compound operator. So what this really means is age equals age plus 1. Okay. Which means this is actually going to change the data because it is an assignment statement. Okay. It is going to change our age data. So age is currently 4 for dog 2. So it's going to get changed to 5. Dog 2 had a birthday and their age increases from 4 to 5. Okay, so now that's going to get stored in memory. Notice how the other dogs, their data didn't get changed. Okay, it is only the references data that was changed here. Okay, dog 1 and dog 3, their age stayed the same. Okay. But now when we go on to the next piece of code, notice how dog 2's age, it stays 5 because we permanently changed the data. Okay. And we changed it with a public method. Okay. Next, it says system.println dog3.say name. Okay, what's going to happen here? Well, here is our method call. Okay, I basically have a method call inside of a method call because system.println is an example of a type of method. Okay, so this says dog3.say name. So dog3 is my reference. Say name is my method. So say name over here, it returns a string. Okay, so this string, my name is name, is going to get returned up to the method that called it. Okay, so with methods that return a value, whatever it returns, think of it like a baseball, it's going to throw that value back to whatever called it, and that value, it's going to catch it. Okay, in this case, system.out.println is going to catch what it returns. Okay, what is it going to return? It says my name is plus name. So in this reference, name is Olive. So what do you think is going to get printed to the screen? Okay, my name is Olive gets displayed. Ooh, sorry, Olive gets displayed. My name is Olive gets displayed. My name is Olive. I should be more descriptive with that. My name is Olive gets displayed. Okay, because that whole string is what gets passed back to that system.out.println. Okay. All right. Let's check out a few other ones. Now we're back to system.out.println. I am plus dog1.peopleyears. Okay, so we're getting a little bit more complex here. System.println I am, and then here's our method call. Dog1.peopleyears. Okay, so in order to display this, first I am going to evaluate what this method does. Dog1.peopleyears. Dog1 people years. Okay, dog1 people years. It's going to return age times 7. Okay, well, dog1, their age is 9. Okay, so I'm going to return 9 times 7. Not only am I going to return 9 times 7, it's an expression that it evaluates. 9 times 7 is 63, hopefully. So it's going to return 63. So I am 63 is what's going to get printed. Okay, I am, and then this method returned 63. Okay. All right, hopefully we're doing good. Let's look at this line of code. This says dog2.changeName Hank. So what's going to happen here? Well, dog2 is our reference, and I'm going to go to the change name method to figure out what's happening. So I go to change name. It takes a string. Okay, perfect. Inside the parentheses, I have Hank. Hank is going to be assigned to new name. It's going to be a placeholder. Okay, because then we take that new name and we're going to put it in my name for dog2. So here, name is Jax. Okay, right now it's Jax. Now, dog2's name is going to get changed to Hank. Okay, nothing. It was a void method, so nothing got returned. Okay, it just changed the name of this dog. All right, let's do dog3.changeGoodness to true. Okay. Maybe you can figure out what this does without tracing the code, but we're going to trace the code. This says dog3 is our reference. Go to change goodness. You're going to pass it true. Okay. So true gets passed to this variable, a Boolean, which is going to be a placeholder here, and it's going to get stored in good dog. Okay. Which means that good dog, instead of false, Olive gets a redemption story arc, and they are now going to be true. Okay, so dog3's good dog now changes to true. And again, when we're changing instance variables, it's just whatever the reference variable is. Okay, so only dog3's goodness changed. Okay, the other dogs are good too. Okay, but only dog3's goodness changed. Just like here, Hank. All of the dogs that were created, all of their names didn't become Hank. It was just the dog 2, which was the reference that we used, changed. Okay. All right, let's look at our last two methods. Here I have a system.out.println, and I have dog2.getDescription, and I'm going to pass it this string. Okay, so it says, okay, dog2 get description. So this separator, this string, is going to get passed to separator. Okay, and that's going to be filled in right here. Okay, so that's a times here. And then name and age, it depends on my reference, right? This is dog 2, whose name is Hank and whose age is 5. So what gets printed to the screen, Hank times age colon 5 is what gets printed. Okay. Remember his name and his age were both changed earlier in the program. Okay. So it didn't start off that way, but because they were both changed and that's his data was changed permanently, that's what's going to get printed. And the last one is dog1.age difference 3. Okay, so dog1, we're going to the age difference method, and it says pass it a 3 to other dog age, which again acts as a placeholder right here. So I have age minus 3. Okay, so age for dog 1 is 9. So this is 9 minus 3, which is 6. That's the best kind of math, right? 6. So it's going to print 6 to the screen because it just wants to print what that value is. Okay, so it prints whatever is returned by this method. Okay, it prints whatever is returned. Okay. And that's all of our examples of those methods we created. Okay. Very exciting, right? I know you're smiling and having a good time on the other side of that screen. So now a few extra things about return statements here. What is returned in the return statement must match what is in the method header. So here I returned an integer value. I returned a 6 and I had an int in my method header. If I tried to return, if this was a double, for some reason I tried to return a double, I would get a compiler error. I have to make sure that the type in the method header matches what actually is returned. Okay. The return statement must always be the last line of code. So all of the methods that we wrote together for the dog, all of them were only a single line. Okay. Now you can have so many lines of code in any method. Okay. But your return statement has to be that very last line. Now I say very last line, we're going to look at some examples in Unit 2 where that's not necessarily the case, and I'll explain that a little bit more in Unit 2 when we get to selection and loops and all of that fun stuff. But for right now, return statement ends the method, and it has to be the last line of code. Okay. Now the value you return to the calling method must fit the value of the variable capturing it. For example, if you return an integer from this method, then you can have a double variable catch it or an integer, but you can't necessarily, if you return an integer and you have a string, you can't necessarily have that mix matched, right? So what we saw, let me go back here. So print line, I returned an int back up here, and I just printed off what that integer was, right? I can't have like Boolean value equals dog1.age difference, dog1.age difference, or whatever. I'm getting a little sloppy here. But I can't have that because this would return an integer, and a Boolean can't capture an integer. I would get an error, okay? You could have, instead of a Boolean, it would have to be an int value capture it. In this case, I just did print statements, and print statements print whatever is given to them, int, double, string, whatever. But if you are returning a value for a variable to capture it, you have to make sure that it matches, okay? And then the last line, again, this isn't really useful right now. It will be useful when we start talking about selection and iteration in the next unit, but I want to make a note of it right now. You can technically put a return statement in a void method in one of these two ways, but return statements usually are not in void methods. Okay. So all of the methods we wrote that were void, you notice we didn't have a return statement. And that's the typical. We're going to see a few minor examples of where you can, though. So I'll put that in there for you. Okay. The next piece we're going to talk about, now that we have the basics of methods, let's talk about a few nitty-gritty areas for these methods. First is overloaded methods. Now, you actually have been experiencing a little bit of overloaded situations when dealing with parameter constructors, okay? Where we said you could have a parameter constructor maybe with 2 parameters, 3 parameters, no parameters, which would be default, right? Those constructors, they all have the same name, dog, right? Which what we've been working with. They all have dog. Well, Java chooses which one to use based on the number of parameters. And it's going to be the same case with methods. Okay? We call methods overloaded when they have the same name but different sets of parameters, just like our constructors, right? When we construct a dog, the program chooses the correct constructor to use based on the parameters that it's given. Same thing with methods. If you have a method with the same name, it's going to choose which one to use based on the parameters. The compiler is only able to choose the method based on the amount of parameters and their type. So it can't distinguish between return types or variable names in the method signature. So very specific, in order to have overloaded methods, it has to have different types of parameters, either different number of parameters or different actual data types. Okay. Let's see an example of what I mean. Okay. Here's a new class. Okay. Oh, let's do something that's not dog. Okay. Just to have an example. Here's public class shape. Shape has one instance variable string. It has a default constructor. Okay. And then it has 3 methods, 3 void methods. These 3 methods all have, notice how they all have the same name. They're all void. Okay. But they all have the same name and they all have different parameters. This has 1 integer. This has 2 integers, and this has 2 doubles, okay? So this method this class as it's written right now is totally good, okay? Good to go. Now, this code, this is going to be located in a method outside of a separate class, and I want to know what is run when the code is executed. So here I have shape1 equals new shape, okay? So 1, the word 1, is going to be the reference to a shape. So a new shape called 1 is created. Here I have a method call, okay? 1.printArea2. So I'm saying, okay, my reference is 1, find the print area in shape and pass it a 2. So which print area is it going to use? Okay. This is where Java is actually, it can be smart sometimes, and it says, okay, I have a single integer. Which one accepts a single integer? Okay. That's going to be this one right here. Okay, so what's going to return? It's going to take that 2. It says, okay, we're going to use this method because this accepts a single integer parameter. So 2 is going to be the value of x. And so when I use this here, x is going to have the value of 2. 2 times 2 is 4. Again, great math, right? So it's going to print off a 4. Okay. Next one, print area 5, 6. It says, okay, again, which one do I choose? I'm passing it 2 integers. Which method over on the left has 2 integers as their parameter? There it is. So 5 is x, 6 is y, okay? Because this is the first one, and this is the second one that gets passed. 30 is printed, okay? Because 5 times 6 is 30. The next one, I have 2 doubles, okay? 2 doubles, which method over there accepts 2 doubles? That one right there. Multiplies them, and you get 6.0, okay? Because it's just a print state. Okay. So that's a little about how overloaded methods work, very similar to constructors in terms of how Java chooses them. Now let's consider adding the following methods to the shape class, okay, or the method signatures, and we would actually make the method. Which of these are valid method overloading examples? And explain. Okay, so for instance, here I have public void print area double Z. So I want to put this into my shape class. Am I allowed to do that? Yes. And the reason is there's not a method signature with a single double. Okay, I have a method signature that accepts 2 doubles. I have a method that accepts a single integer, but I don't have a method that accepts a single double. And because of that, this is a valid one. I can add this and I'm good. What about this one? Okay, it accepts a single integer. Can I add it? And the answer is no, because this one already accepts a single integer. I do have different return types, but overloading does not apply to return types. So just because I have different return types, it does not matter. The only thing that matters is the parameter list. Okay, so this is invalid. There's already a method signature with a single parameter. Okay. Here's one, an integer, single integer, but I just said this one has a single integer. Oh, but they're named something different. One has X, one has Z. Is this valid or invalid? Unfortunately, it is invalid. The compiler will not distinguish between not only the names, but also, did you notice the visibility modifier? This one was private and this one was public. Okay. So because I have different public and private, it did not matter. Because I had different X and Z, it still did not matter even there. Okay. It is only the type and number of parameters. Okay. What about this one? Public void print area double X double Y double Z. This is valid because there's not a method signature with 3 doubles. So you can add this one, in fact. Yay. Okay. We are almost to the end here. I have one more example, the animal class, and then I'm going to finish up the lesson talking about commenting techniques. So we're almost to the end here. If you wanted to pause this and try to answer the questions before we go through this, feel free, because we're now in practice mode here. Let's have a new class, public class animal, and we're going to figure out what the following code segments print. Now, you'll see this a lot on the AP exam. They'll say something like, assume the animal object is created in a class other than animal. We are doing all of this code segment outside of the class animal in order to be able to run it. You can't create an object inside of the object itself. It doesn't work if you do that. So all of these have to be in a separate class, like a main method inside of a driver class. Okay. So over here in animal, let me just do a quick run through of what's happening. I have one instance variable. I have a default constructor that sets type to unknown. I have a parameter constructor that sets it equal to whatever type it's passed. I have a couple of void no parameter methods here, and I have 3 void methods with parameters here, okay? And there's some fun things happening inside those methods that we're going to talk about, okay? So here I have animal A equals new animal. So remember, this creates A as a reference, and I use the default constructor, so it's an unknown type. This line says A.talk, which means that I'm going to talk, and it says, hello, I am A. So that gets printed to the console. And then I have a.sayName, okay? And right now the type is unknown. So when I say a.sayName, and in here it says print the type, it says go to your reference A and print off the type, which is unknown, okay? That gets printed off on the same line as hello, I am A, because this was a print statement. So the cursor didn't move to a new line after it was done printing hello, I am A. Okay. All right. And that was the first example. We're going to look at a couple more code segments. Okay. Again, if you want to pause and try them, feel free, but I'm going to go through what the answers are here. I say animal B equals null. Okay. So null is what happens when we just create the reference, but we don't actually make the object. Okay. This would also be the same as if I said animal. Well, I guess I should be careful. Let me ignore that example because this actually will be caught by the compiler. It'll say something about B was created but not instantiated. So I forgot. This is actually caught by the compiler. If you don't have B equal to anything else anywhere in your code, your compiler will say, hey, hello, you created an animal, or excuse me, you created a reference, but you actually didn't create the object. Okay. So that's why if I have animal B equals null, null is a valid reference for an object to point to. Null technically means you're not pointing to anything, okay? But, excuse me, I'm sorry. But this is recognized by the compiler and it will compile fine. When I go to say b.talk, because I didn't create an animal, I didn't use the new keyword, I didn't use any constructor, B is not pointing to any data in memory. So when I go to even try talk, because talk doesn't even use any data here, right? There's no data being used. It's just a print statement. It still will not allow me to run that code because B is not pointing to any object, right? So what you're going to get is a runtime error called null pointer exception, meaning that B is pointing to nothing. Okay, B is not being referenced to any sort of data. Okay, so null pointer exception. Let's create two new animals. Using C is using the parameter constructor, and D is using the default constructor. Gosh, I'm losing my mind this late in the video, but C and D. So what's going to happen? If I say d.sayName, okay, D is pointing to type unknown. So here I'm going to print off unknown. C.talk says hello, I am a. Okay. And then when I say C.sayName, the type of C is going to be kitten. Okay. So hopefully that looks okay. I would say ask a question, but you really can't ask a question on the video. Let's try this. Animal F equals new animal whale. So I'm using the parameter constructor. And then I say f.greet. Okay. What's happening here? Inside this greet, I have two method calls. Beautiful. Okay. But these method calls don't have a dot in front of them. Okay. So what is going to happen? Okay. Well, because talk and sayName are both located inside the animal class that it's being called in, what Java will do is it'll say, okay, I see talk up here, and it's going to use the same reference for talk that greet was used with. Okay, so basically kind of, I don't want to say pass the reference because that's implying it's used as a parameter, but it uses the same reference that greet was called with. So it's basically saying, okay, F called greet. Now F is going to talk, which is, it's going to say, hello, I am a. Okay. Next we have sayName. So after that runs, okay, so that's done, that ran. Now we have sayName. sayName is going to run. So it's going to be basically F calling the sayName. Okay. F.sayName means we're going to do type F. What is type F? F is a whale. So whale is going to get printed on that same line. Okay. Ooh, fun. When we have method calls inside of method calls, that's when stuff gets real spicy in computer science. Okay. We have hello, I am a whale using two method calls inside of the animal class. Okay. That's beautiful. I love it. Okay, let's try this. Animal G equals new animal, zebra. Okay, here's our object. It's created. It's beautiful. G.talk for. Okay, did you notice? Talk, no parameters. Talk with parameters. Okay, I forgot to point that out before. Talk with no parameters, talk with parameters. And again, this is an overloading example. And Java is smart enough to know which one to use. It knows that if you have an integer inside of those parentheses, it's going to look for the method that has an integer, accepts a single integer. So you're going to put 4 into age here. Okay. And it's going to print off that value. I am 4. Okay. When you go to this one, this has no parameters. So it knows to pick this one. And it knows to print off, hello, I am A. Okay. And then we just kind of end there. Okay. Animal H equals new animal rat. H dot say name Queenie. Okay, so H is a type rat. H dot say name. Again, we have say name and say name. So when we have a string inside, it says, okay, I'm going to find the say name method that accepts string. And it's going to print my name is, and then it's going to print my name is Queenie. Okay. And our last example, I think this is our last example here. We have Gus. Animal J equals new animal, J.getInfo 3, Gus. So J is created. J is our reference to the get info. Okay. Get info passes 2 parameters, 3 into A and Gus into N. Okay. So when I do talk A, 3, again, this A is kind of a placeholder. So 3 goes in for A. And then when I do talk 3, 3 gets passed to age. Whew. And then I am 3 gets printed to the council. Oh my gosh. Okay. Kind of got to follow that chain here. Here's the chain. It's not a great chain, right? 3 is passed to A here. A is passed to talk. A is passed here, but then A becomes age and prints 3. I am 3. And then system.out.println, this is code for just creating a new line because the talk just printed to the end, right? And then the cursor was waiting there. This line of code moves the cursor to the next line. And then I have say name N. So N, Gus was passed to N. So Gus is going to be passed to say name. Okay, so say name is right here. Gus goes here. So my name is Gus gets printed on its own line. That looks beautiful. That was amazing. That truly was. Okay. All right. Another example of using all of those methods. Okay. Very fun. All right. We have reached almost the end of our video. I want to just briefly talk about commenting techniques in Java. So we've talked about how comments just make it easier for yourself as well as other programmers to read and how the compiler ignores all comments. Okay. We have our block comments that are used for longer explanations. And then we have single line comments. Okay. So used for brief notes. Most of us have used just the single line comments up to this point so far. Okay. But block comments, everything between these two symbols is ignored by the compiler. Okay. Everything just on the single line is ignored after the 2 slashes here. Okay. Now, we also have Java doc comments. So this is very specific to your IDE where you can find your API documentation. But Java doc comments allow for you to make comments in your code that is read by this API documentation, and it kind of puts it into a template. So if you make a long program and you use very specific types of comments in this long program, you are then able to use the API documentation template. Now, all IDEs kind of use it, I don't want to say use it differently, but have it in different places. So look to see where your specific IDE has this. But this API documentation looks like this, okay? So here I have a method called calculate area. Right above that method, I have what's called a Java doc comment. So it starts off with and ends with that block comment. And now between those are very specific, it's a very specific type of comment that I use so that it's read correctly by the API documentation. Okay, there's a little star here. Each line starts with a star just to help it organize it into the template. Okay, it says first calculates the area of a rectangle. So this would be the purpose of what the method is. Then I have at param. It's not parm. Param. Okay, that stands for parameter. Okay, so this says what the two parameters do. At param length and at param width, it defines what each of those parameters are. I guess a good description so that anyone who reads this understands what's being passed to this method. And then we have at return. So what does this method return? This method returns the calculated area. Okay. So it's a way to write it. It's not required by any means. You don't have to put this into your code, but you might see it in other people's programs or even on the AP exam when they talk about, when they give you certain, for lack of a better term, parameters for your method and what you have to create. Okay, so I just want to show it to you, explain it a little bit so that when you see it, you're not super confused. Okay. Special notation indicate what the parameter represents, what the return value represents. Okay. Here's a special thing that happens on the AP exam, what we call pre and post conditions. Okay. A precondition is something that must be true before running a method for it to work as expected. Okay. Programmers do not expect methods to verify preconditions themselves. Okay. So like a precondition of this calculate area would be that the width and the height must be positive, right? In order to calculate the area of an object, you have to have positive width and a positive height, right? Just positive. You can't have negative lengths. So this would be a precondition. It would say the integers that you are being passed are positive, must be positive. So you don't have to write code to confirm that, or code to fix it if it's not positive. Okay, a precondition is what is true, and you can assume it's always true. Versus a postcondition two is something that must be true after the method finishes running. Okay, so like this method returns the correct area of the rectangle. So this is going to be true. It's going to return the correct area after it has successfully stopped running. Okay. Oh, and that is the end of that. Look at that. We made it to the end. The black screen tells us end of slideshow. So thank you guys so much for following along in this lesson. If you liked this lesson, please hit the like button and subscribe to my YouTube channel for more great computer science content. Until then, thank you for sticking with me for this long video, and I will see you in the next lesson.